Okay, so this video is about spec point 1.1.2. So spec point 1.2 is all about water, and it says to understand the importance of water as a solvent in transport, including its dipole nature. So first of all, let's concentrate on water being what we call a solvent. And secondly, let's look at what it means by saying it's got a dipole nature. So starting off with the solvent. So the reason why it's really useful that water is a solvent is because solutes can dissolve in it. Okay, so that's the definition of solvent. So solutes, spell it properly. So solutes can dissolve in it. So solutes dissolve in a solvent. So if you were at home, you might say sugar dissolves in water. We're more interested in molecules dissolving in the blood in order to be transported around the body. Okay, so solutes dissolve in water. Okay, and the reason this is useful is because various molecules will dissolve in the blood for transport. Okay, so in animals, we're talking about molecules dissolving in blood to be transported around the body. So for example, oxygen, carbon dioxide, things like that. They'll dissolve in the blood, they can be transported around the body, get to where they need to be. Remember that also this spec talks about plants, so it could talk about molecules dissolving in water in plants. So we could talk about the minerals coming in through the roots, dissolved in water, travelling around the plant, something like that. Okay, so it's really useful that substances dissolve in water, which is useful for transport. Now, this word dipole, this is to do with the structure of the water. So we all know that water is H2O. Now, if we were to draw H2O, we've obviously got H2, which means we've got 2 hydrogens, O, which means we've got 1 oxygen. Now, the charges of those are very small but significant. Now, because they're slightly charged, we use this little symbol to show that it's a slight charge. So the hydrogens are slightly positive. So we draw it like this, slightly positive. And the same on this one, slightly positive. That's what that means, okay? And the oxygen is slightly negative. Now we call this a dipole because it's got 2 opposite charges, okay? It's got a slightly positive side and a slightly negative side. Now, as we go through the course into year 13, we start to learn that water molecules actually are quite sticky. They stick together. And if we were to draw another water molecule just here, if we add on that the hydrogen here would be slightly positive, slightly negative, what actually happens is there's some attraction between this positive and negative, okay? And that's why water molecules tend to stick together, and that's why, for example, the transpiration stream works. So when water evaporates out of the leaf through the stomata and it pulls more water up the xylem behind it, the reason why, if they're evaporating out of the top of the plant, they pull up this column of water, it's because the water molecules are sticking together because of the slightly positive and slightly negative charges attract together. Okay, so we call this a dipole because it's like it's got 2 poles. It's got a positive and it's got a negative. Okay, and that's all there is to spec point 1.2.